Imagine this traveller. You weren't drawn here by chance, but by a quiet gravity the universe sometimes uses to guide an observer toward a story that matters. What are the odds that an interstellar wanderer, a fragment that spent 10 billion years between the stars, would brush past Venus, a world so harsh that even Soviet landers survived only minutes, and yet leave behind molecules that refuse to die? A silent object gliding through the inner solar system, a delivery no planet has received in eons, a disruption measurable against billions of years of calm. Stay with me, let's drift a little deeper. Traveller. Tonight, the universe whispers again. And it whispers through the heavy layered sky of Venus, a world we once believed was silent, finished and unchanging. But nothing in this cosmos ever truly sleeps. Not even a planet wrapped in acid and fire. When 3i Atlas passed nearby, something delicate drifted from its ancient breath into the waiting atmosphere below, and the quiet machine of Venus began to stir. We tend to speak of Venus as a single hostile realm, a furnace, a pressure chamber, a place where life's fragile chemistry dissolves in seconds. But beneath that simple description lies a system older and more intricate than any mythology we've told about it. Venus is not merely hellish. It is layered, structured, deliberate. And when something foreign arrives, each layer responds in its own slow language. Picture the atmosphere not as a clouded shroud, but as an ocean standing on end. The upper haze is one current, the middle another, the depths yet another. 3 zones, 3 shifting worlds stacked vertically above a surface no human will ever stand on unaided. And into this ocean of suspended acid the comet's molecules fell, like seeds scattered on a restless tide. They did not fall into one world, they fell into many at once. High above, 60 to 70 kilometers, lies the thin, cold realm where sulfuric droplets float in concentrations that almost seem gentle by Venusian standards. Temperatures here skim just below freezing. It is a place where water, that ancient storyteller of worlds, can condense into crystals before the sunlight erases their memory. Molecules arriving here drift with long, patient steps, because collisions are rare. Low pressure stretches time, and in that slow time traveller chemistry lingers. Molecules persist, reactions wait, as if listening for what comes next. This upper layer is where Venus breathes horizontally. Winds circle the entire planet in only 4 Earth days, a superrotation so fast it seems impossible for a world that turns so slowly. Anything entering here is swept around the globe with astonishing speed. Nothing remains local, nothing stays where it falls. The comet's materials became global travellers within hours. Below that, the middle cloud deck thickens. Temperatures sink further. Acidity sharpens. This is the region where cameras aboard orbiters trace graceful Y-shaped structures and spiralling vortices like brushstrokes on a cosmic canvas. Here, molecules that survive the gentler upper haze encounter something more decisive. The acid becomes strong enough to transform them. Some break apart, some dissolve, some merge into droplets rather than float alone. And deeper still, the lower cloud layer presses inward with a kind of chemical inevitability. Temperatures fall to levels that no poem can warm, and yet reaction becomes more forceful. Organic structures that travelled bravely through the upper skies often meet their final moment here. They are broken into smaller truths folded into droplets that evaporate before they can touch the surface. Venus rarely allows anything to reach its ground. Instead, it recycles everything in a looping cycle of rise, fall and return. This is the conveyor belt of Venus, a closed rhythm older than Earth's continents. Sulfur dioxide rheases, light fractures it, acid forms, droplets fall, droplets evaporate. The cycle repeats without pause, without mercy, without visitors, until now. Because when 3i Atlas passed by Traveller, Venus received what it has not tasted in billions of years: external chemistry. Water vapour, hydrogen cyanide, dust-carrying refined nickel, organic fragments built in the dark between stars. None of these belong to Venus. None of them fit the patterns the planet has memorised over eons, and so the atmosphere-layered ancient precise began responding. Light molecules descended deeper. Heavy grains lingered above. Each found its proper layer, its correct stage in this atmospheric symphony. Water entered the upper haze and softened the acid. Hydrogen cyanide slipped into denser layers and cracked open into ammonia and formic acid, an unexpected gentleness born from violent surroundings. Nickel dissolved into droplets and became something more than metal. It became a catalyst, a quiet accelerator, a teacher of reactions. Imagine this listener. After billions of years of predictable chemistry, Venus encountered novelty. Foreign molecules that didn't belong, traces of another star system, and instead of rejecting them, the planet absorbed them, processed them, transformed them into new species that have never existed there before. A perturbation so small in mass yet so vast in meaning. Somewhere in that layered ocean of acid and wind complexity began to bloom not life, not intention, but possibility. Organic fragments survived longer than expected. Reactions unfolded in droplets like whispered experiments. A world long believed hostile proved to be selective, not destructive. It keeps what it finds useful. It dissolves what it does not. This is why scientists watch with trembling curiosity. This is why astronomers speak softly when discussing November 3rd. Because Venus, a planet we thought we understood, is now exploring chemical pathways it has not touched in geological time. And tonight, as you listen beneath whatever sky covers you, the clouds of Venus are still moving, still reacting, still carrying the comet's gift through a circulation so swift it would dizzy the human mind. These molecules, these visitors will live brief lives there. Weeks, perhaps months. But their effects ripple across a world that once knew only its own cycles. It's all right to not understand everything at once. The universe rarely reveals its meaning in a single gesture. Some mysteries aren't meant to be solved, only observed. So rest with this thought traveller. A comet older than memory brushed past a planet drowned in acid. And for a moment the chemistry of Venus dreamed of something new. Sleep, traveller. The cosmos will keep watch. Traveller. As we drift deeper into this story, imagine descending through Venus's atmosphere the way a thought drifts into a quiet mind. Slowly, carefully, without resistance. The layers thicken, the chemistry darkens, and the foreign materials from 3i Atlas begin to choose their paths. Every molecule becomes a traveller too, carried by winds that never rest. Begin at the boundary where space surrenders and atmosphere begins. Here above, 100 kilometers, incoming particles shed their cosmic velocity in a blur of collisions. Water vapor, hydrogen cyanide, tiny grains of nickel-bearing dust, each slows. Each warms, each transforms. It is not a violent entry, but a soft capture like fingers closing around drifting seeds. Light molecules are stubborn wanderers. They slip through the slowing currents, penetrating deeper, stretching their journey into the cloud layers below. Heavy grains surrender sooner. They settle into the higher regions, suspended like memories the planet has not yet decided to keep or discard. Nothing falls straight downward. Venus does not allow straight lines. It accepts things in spirals, in loops, in drifting motions shaped by temperature, wind and time. Superrotation begins its work almost immediately. Though the planet itself turns slowly a single day longer than its year, its upper atmosphere races around it in a 4-day embrace. Winds reach 100 meters per second faster than hurricanes, yet strangely gentle in their constancy. Anything entering these heights is taken into the global chorus, carried from morning to night, from night to day endlessly. Further down, circulation deepens. Traveller, imagine the atmosphere as a set of nested tides rising at the warm equator, sinking at colder poles, each movement dragging the comet's gift along pathways carved across eons. Venus does not hoard what it receives. It redistributes, it stirs, it blends. The chemistry becomes global within days. Temperature, that ancient sculptor of molecules, carves the fate of each arrival. In the upper cloud deck near freezing water, condenses organics stabilize, and reactions pause suspended between possibility and dissolution. In the middle deck, acidity sharpens, temperatures drop lower, and the foreign molecules face harder questions. Who will survive here? Who will change? Who will surrender to the acid? Hydrogen cyanide does something unexpected, something quiet, something intimate. It dissolves into acid droplets and hydrates, transforming into ammonia and formic acid. These reactions occur without sound, without spectacle, but their implications are immense. Ammonia softens the acid. It lifts the chemical mood of each droplet, raising the pH in microenvironments scattered across the clouds. And wherever acidity softens, complexity steps forward. This is where the chemistry becomes reflective, almost contemplative. Droplets become miniature laboratories, each one testing whether molecules from two worlds can learn to coexist. The results are not dramatic. They are subtle, persistent and patient like thoughts, shaping themselves beneath consciousness. Nickel dust, once part of the comet's metallic heart, dissolves into solutions and becomes a catalyst. Metal that drifted through interstellar darkness now accelerates reactions inside floating beads of acid. It is a quiet kind of guidance, the way a stone placed correctly in a stream alters the entire flow. Nickel doesn't dictate outcomes. It merely makes pathways easier, energies lower, possibilities wider. Traveller, consider this for a moment. Without intention or awareness, Venus is performing chemical experiments on a planetary scale. Tens of billions of droplets, each containing a mix of water acid, organics, and metallic catalysts, cycle through layers warm and cool, rise and fall. Chemical histories are written inside these droplets, erased by sunlight, then written again. The atmosphere becomes a book written in dissolving ink. And still it tells a story. This story is not one of life, not yet. It is a story of precursors, of foundations, of conditions that gently lean toward complexity. Early Earth once held reactions like these in tidal pools, hydrothermal vents, shallow lakes. Venus holds them in airborne acid rain that never touches the ground. Somewhere in these clouds, reactions unfold that have not unfolded on Venus for billions of years. Organic molecules remain intact longer than expected. Amino acid surrogates survive in acid that should destroy them. Nickel catalyzes formations it has not catalyzed since long before our sun existed. 3 Atlas did not bring life. It brought possibility, the oldest gift the cosmos knows how to give. And possibility does not need land oceans or warmth. It needs gradients, energy cycles, and time. Venus has all 4. Even now, the droplets are exploring, branching into unfamiliar chemical pathways, forming products that will exist only briefly before sunlight unravels them again. But brief existence is still existence. Even momentary complexity leaves echoes. What you're hearing tonight is not drama, but emergence. The quiet, patient unfolding of chemistry in a world we once dismissed as dead. Venus is not dead. It is processing. It is thinking in chemical rhythms far slower than thought, yet no less intricate. Silence Traveller is the universe thinking, and Venus is thinking now. By late November, the foreign molecules were no longer arrivals. They had become participants aligned with circulation mixed into haze dissolved into droplets. Some rode the winds toward the poles, where descending air compressed them gently into smaller spaces. Some drifted upward, touched by UV broken into radicals that began new reactions. Others merged into the endless cycle, rising, falling, evaporating, and beginning again. The redistribution is not random. It follows the rules written by physics, written by heat, written by the slow spin of a planet that remembers being young. 3i Atlas simply introduced new letters into an ancient alphabet. Venus in response began writing new word. And as this happens, Traveller remember one truth that rests beneath every scientific detail. You're not lost in space, you're part of it. The same chemistry unfolding on Venus once unfolded on Earth. The same molecules drifting in Venus's clouds once drifted through the nebula that became you. Some mysteries aren't meant to be solved, only observed. Tonight, Venus is not a furnace, not a warning, not a myth. It is a laboratory carried by wind. Rest in that thought. Let it settle over you like the upper haze settling over the planet. The universe experiments slowly and gently, even in places of fire. Sleep, Traveller. The cosmos will keep watch. Traveller. Let us drift further into the clouds where the quiet transformation continues. To understand what Venus is doing with the comet's gift, we must listen to the rhythms beneath its storms, the slow layered chemistry that has remained unchanged for billions of years. But now interstellar molecules move within it like soft disturbances reshaping pathways that have not shifted since Venus was young. Before the comet's arrival, Venus's chemistry lived in equilibrium. Not peaceful, not gentle, but stable. a cycle of rising sulfur dioxide sunlight splitting it apart, droplets forming droplets, falling droplets evaporating. Over and over. The planet maintained itself like a machine running on ancient rules unbroken by time. Nothing from outside ever entered. Nothing new disturbed its balance. But 3C Atlas broke that silence, and when novelty enters a closed system, even in tiny amounts, the system must respond. Imagine the foreign molecules settling into the layered atmosphere. Water vapour softens the acid. Hydrogen cyanide dissolves and transforms. Nickel ions awaken catalytic reactions. Each material follows its own path, shaped not by intention, but by physics, gravity, temperature and light. Venus becomes a conductor, orchestrating a chemical symphony it did not expect to perform. Water, once captured, does not wander idly. It condenses into droplets, mixing with sulfuric acid in subtle proportions. The acid grows slightly less aggressive, creating pockets of conditions previously impossible. Local humidity increases. Reaction rates shift. These may seem like small perturbations, parts per billion, but in planetary chemistry, even the smallest imbalance can ripple across cycles, transforming behaviour. Hydrogen cyanide is more intriguing still. It slips through the atmospheric layers like a quiet intruder, dissolves into droplets, and immediately begins to hydrate. HCN becomes ammonia and formic acid, two molecules that carry potential rather than destruction. Ammonia especially is transformative. It neutralizes acidity inside droplets, creating temporary microenvironments where organic chemistry can breathe, if only for a moment. Nickel, however, is the molecule that changes the story's tone. Dust grains carrying refined nickel dissolve quickly, releasing ions into droplets. Nickel is more than a visitor. It is a catalyst, a guide, a subtle accelerant of reactions that would otherwise remain dormant for geological ages. The atmosphere becomes a network of millions of tiny reactors, each one performing variations of reactions never before seen on Venus. This is the awakening traveller. Not life, but the conditions that whisper of its foundations. Consider how droplets behave in Venus's winds. They rise slowly into regions of harsher light, where UV radiation splits water into hydrogen and oxygen, or cleaves organic molecules into smaller radicals. Yet even these radicals can recombine into forms more complex. Droplets fall again into cooler layers, carrying newly forged products that were impossible moments before, and the cycle continues: rise, transform, fall, evaporate, a silent dance of chemistry guided by sunlight and motion. This is not chaos. It is exploration. It is complexity assembling itself in fleeting increments. In these moving droplets, reactions become intertwined. Water reacts with carbon monoxide accelerated by nickel catalysts. Hydrogen generated in these reactions may escape into space, altering the atmospheric balance slightly, and exhale from the planet into the cosmos. Organic precursors assemble, break apart, and reassemble into forms unfamiliar to Venus's long chemical history. The atmosphere is learning. It is processing the interstellar materials in ways that stretch beyond expectation. Think listener about the implications. A planet we once deemed sterile now reveals a subtle openness to chemistry associated with life's early steps. Amino acid precursors persist in acid that should erase them. Organic fragments stabilize long enough to participate in new reactions. The droplets rich in sulfuric acid become microreactors, where complexity can grow before sunlight unravels it again. This is prebiotic chemistry, fragile, temporary, beautiful in its impermanence, and it is happening above a world of crushing pressure and molten surface where nothing we recognize as a life could ever walk. Venus's clouds have become a floating laboratory, a quiet cradle of experimentation suspended above fire. Traveller, the molecules delivered by 3I Atlas now drift through circulation loops of breathtaking scale. Superrotation carries them around the planet in 4 days. Hadley cells lift them, sink them, concentrate them in polar vortices. Sunlight breaks them. Darkness shelters them. Temperature gradients sculpt them. Venus responds not with violence, but with curiosity, the chemistry's version of a deep, slow breath. Weeks after the delivery, foreign materials no longer remain near their arrival point. They are diffused globally, diluted, yet detectable in spectral fingerprints. Some accumulate in downwelling regions, others persist in layers shielded from UV radiation. Even in their decline, they leave traces, chemical echoes, a memory inscribed in acid and light. Consider how long it has been since Venus last received such a gift. Billions of years since anything external entered its equilibrium, and now, suddenly, materials from a star system across unimaginable distances swirl in its skies. A planet closed to the universe briefly opens. Chemistry that once felt stagnant becomes dynamic. As observers, we watch from afar, piecing together infrared data, ultraviolet scattering absorption lines, etched into spectra like delicate handwriting. We do not see the droplets directly. We see how they change the light that passes through them, and from that light we reconstruct the story of Venus's awakening. There is humility in this. We are not witnesses in the clouds, we are interpreters of glimmers, but this distance brings something profound. The understanding that planets are not static. They are reactive, they are sensitive to the smallest external touch, and when touched they change not dramatically but delicately like ripples across still water. Tonight traveller rest in the knowledge that even worlds shrouded in acid and fire can transform quietly. That chemistry is patient, that possibility is enduring, that the paths toward complexity often begin unseen in places we once dismissed. Some mysteries aren't meant to be solved, only observed. Let Venus teach us this. Close your eyes now. Let the slow winds of that distant world move through your imagination like a lullaby made of sulphur and starlight. Sleep, traveller. The cosmos will keep watch. Traveller. Let us return to the upper reaches of Venus, where the atmosphere behaves less like weather and more like an ancient breathing organism. To understand what 3i Atlas has done here, you must imagine the planet as a layered ocean of chemistry rather than a solid world. Every molecule entering its skies is greeted not by impact, but by absorption, a gentle surrender into currents older than any life we know. Nothing falls straight down. Everything becomes part of the great circulation. Far above the clouds, in the thin thermosphere, incoming molecules begin to lose their velocity. They collide softly with native gases, slow their descent, and dissolve into the invisible machinery of atmospheric flow. Water vapor, hydrogen, cyanide, carbon, monoxide, and dust grains carrying refined nickel are all guided downward at different speeds. The lightweight molecules penetrate deeper. The heavier grains linger in suspension, awaiting the chemistry that will claim them. Once captured, these molecules are drawn immediately into Venus's great superrotation. Winds circling the planet complete one full lap in only 4 Earth days, sweeping foreign material horizontally in ribbons that stretch across continents of cloud. This is not a violent storm, but a rhythmic conveyor that redistributes chemistry around the globe with astonishing efficiency. Within hours, material that travelled 10 billion years now circles a world of acid and light. Vertical motion adds another layer of complexity. Warm regions rise, cooler regions sink, and the atmosphere forms vast three-dimensional currents like slow-moving rivers. Upwelling near the subsolar point lifts foreign molecules higher. Downwelling near the poles concentrates them, creating quiet pockets where reactions intensify. Venus does not mix its new ingredients carelessly. It folds them through its circulation with a precision shaped by physics, light and time. The moment of arrival was delicate and strangely perfect. On November 3rd, Venus's late morning hemisphere faced the comet's outgassing stream. Sunlit winds were rising, the atmospheric door was open. Material drifting from 3i Atlas entered this upwelling, and was immediately carried into superrotation, blending seamlessly with the planet's breath. A single encounter lasting only hours became the beginning of weeks of redistribution. Now in the upper cloud layer, where temperatures hover just around freezing water, vapour can condense before the acid consumes it. Organic molecules survive longer here, sheltered by low pressure and slow reaction rates. One can imagine droplets forming around nickel ions, refracting sunlight as subtle reactions begin within them. These droplets become tiny vessels where complexity can spark momentary pockets of possibility drifting in an endless sky. Photochemistry, however, never sleeps. Ultraviolet radiation fractures molecules, generating reactive radicals that either collapse into simplicity or recombine into unexpected structures. Hydrogen atoms split from water drift through the atmosphere before merging into new compounds or escaping into space. Cyanide radicals react with ammonia, forming organics that Venus has never hosted before. In these high altitudes, creation and destruction share the same breath. Deeper the middle cloud layer grows harsher. Acid concentrations rise. Temperatures fall. Here hydrogen cyanide dissolves readily, transforming into ammonia and formic acid. Nickel dissolves into sulfate, granting droplets catalytic potential. Organic fragments cling to droplets or become incorporated into their liquid phase. Every transformation nudges Venus a little further away from its long-held equilibrium, shifting its chemistry in subtle but profound ways. The lower cloud layer remains the end of the line. Pressures climb toward one Earth atmosphere. Temperatures sink to unfamiliar cold. Molecules arriving here rarely survive intact. They are broken down, rearranged, or evaporated as rising heat redistributes vapors upward again. This cycle descend-transform. Ascend has shaped Venus for billions of years, and into it the comet's molecules now blend, learning the rhythm of a world that tolerates nothing unchanged. Still, traveller, the foreign chemistry lingers. Though diluted, its presence is unmistakable. Spectral signatures reveal traces of water, hydrogen, cyanide, and nickel compounds in places where they should not exist. Downwelling regions near the poles contain slightly higher concentrations, as though Venus is gathering the comet's materials in quiet chambers of chemical reflection. Even in their decline, these molecules leave patterns, faint echoes of an interstellar encounter. Imagine Venus as a planetary alchemist. It absorbs whatever arrives, breaks it down, transforms it, and reincorporates the pieces into cycles that have run since its birth. But this time the inputs are not native. They carry the chemical memory of another star system. They hold the deep time imprint of processes that unfolded long before Venus ever existed. Within the droplets drifting through its clouds, these memories now interact with Venusian chemistry, blending ancient histories across light years. This is not the emergence of life. It is the emergence of complexity. In droplets enriched with water, ammonia, formic acid, and catalytic nickel reactions occur that Venus has never hosted. Organic chains lengthen briefly before breaking. Reductions and rearrangements form transient molecules. The droplets become miniature laboratories where the universe tests possibilities, knowing most will perish, but accepting that a few may evolve into something unexpected. As observers, we learn through indirect signs. We read the faint shading of absorption lines. We compare scattering angles. We measure temperature gradients. From these clues, we reconstruct the invisible dance unfolding in the clouds. Our instruments do not touch Venus, yet they feel its pulse. Through light alone, we watch a world explore chemistry older than life and younger than meaning. Tonight, traveller, find comfort in this quiet transformation. Venus changes in whispers, not catastrophes. It receives a visitor from the stars and responds not with fear, but with curiosity. And in that curiosity lies a lesson even the harshest worlds have room for new stories. Even equilibrium is never truly permanent. Even silence can think. Rest knowing this, you are not lost in space, you are part of it. Some mysteries aren't meant to be solved, only observed. Sleep, traveller. The cosmos will keep watch. Traveller. Now we step into the realm of evidence, where Venus no longer changes in silence alone, but begins whispering its story through the instruments watching from orbit. Nothing about this world is simple, and every answer hides behind layers of clouds, radiation, and interpretation. To understand what 3i Atlas has done, we must learn to read the faintest signals, the way light bends, scatters, or fades as it passes through the atmosphere of a planet both hostile and strangely delicate. Akatsuki, the lone observer positioned well for the encounter, recorded the moment foreign chemistry arrived. Its sensors watched the clouds, measured their brightness, traced their circulation, and captured the hidden fingerprints of new molecules. Yet the data travels slowly, encoded across millions of kilometers, arriving at Earth as fragments awaiting reconstruction. Before the story is known, it must be calibrated, corrected, interpreted. Science rarely moves fast, it breathes in long, patient cycles. This is the waiting phase, traveller. A time when the universe knows exactly what happened, while we piece the truth together one photon at a time. The data exists all of it, but meaning does not arrive with measurement. It emerges through discussion, comparison, and the slow art of understanding. Scientists will debate, refine, and test their explanations until certainty forms like dew on a window at dawn. If the models are right, Akatsuki will reveal slight increases in water vapor, the quiet presence of hydrogen. Cyanide perhaps trace amounts of nickel compounds, where droplets reflect light differently. These changes will be small, almost ghost-like. Spectral signatures may shift by fractions, cloud textures by degrees, but in Venus's stable system, even the slightest deviation is a revelation, a whisper of disruption travelling across an ancient atmosphere. There is humility in studying a world through distant eyes. We cannot reach out and touch these droplets. We cannot hold a sample or peer directly into the storms. We rely on the way sunlight is filtered on the shadows cast in ultraviolet and infrared. Venus speaks in wavelengths, and we answer with algorithms. It is a dialogue of patience, a quiet conversation across space, where both sides speak slowly, as though afraid to disturb the darkness. While Venus processes the comet's chemistry naturally, Mars faces a slower fate. The materials delivered there lie frozen on the surface, waiting for robotic excavation years in the future. Two planets, one comet, two entirely different responses. Mars conserves. Venus transforms. In that difference lies the beauty of comparative science, the recognition that in a universe governed by laws, each world still behaves like an individual. For now, the scientific community prepares for what comes next. Papers will appear early next year, each presenting fragments of understanding. Observatories on Earth continue to track 3i Atlas, as it fades from the inner solar system, still outgassing but slowly diminishing. The comet becomes quieter now, like a traveller retreating from a conversation having already delivered the message it carried across interstellar darkness. Meanwhile, the data from Venus settles into servers waiting for careful minds. Nothing about this analysis will be rushed. Spectra must be compared against models of cloud layers. Scattering patterns must be separated from noise. Chemical pathways must be mapped with precision. Only then will we know exactly how deeply the comet reached into the planet's atmospheric cycles. Traveller, imagine being one of the scientists who must read this mystery. You spend nights staring at faint lines on a screen, each one representing a story in the wavelengths. You compare a baseline spectrum with a new one, and notice a tiny deviation, a dip, a rise, a missing peak. No one else would see meaning there, but you sense a shift. A molecule that was never meant to be present in Venus's atmosphere now leaves its fingerprint in the light. The realization is quiet, almost sacred. Science moves not in sudden exclamations, but in soft confirmations. Yes, something changed. Yes, something foreign is drifting in the clouds. Yes, Venus is processing the comet's gift. These small affirmations ripple outward, forming the basis of understanding. Venus becomes a teacher, showing us how a planet responds to chemistry from beyond its own star. And in this, we learn more, not just about Venus, but about the possibilities that exist across exoplanets, worlds we cannot see yet, but whose physics mirror our own. Think of this, listener. If sulfuric acid clouds can host prebiotic chemistry even briefly, then life's potential playground is wider than we imagined. Venus becomes a demonstration, a cosmic lab showing that complexity does not require kindness, only opportunity. Even in environments hostile to life as we know it, the foundations of complexity may dance for a moment before dissolving again. Scientists will chase these implications as eagerly as they chase the data. Questions will bloom. How long do foreign molecules persist? Do they trigger secondary reactions? Could complexity survive longer than expected? Do other planets receive similar gifts from interstellar travelers? How common is chemical exchange between worlds? The next 18 months become a slow unfolding of answers. Mars data will confirm deposition patterns. Venus data will map atmospheric responses. Models will be refined. Synthesis papers will connect the stories of both planets. Nothing dramatic will happen in real time, but understanding will deepen like sediment on the ocean floor. And through all of this, traveller, one truth remains steady. The universe does not rush. It reveals itself in patient increments. It invites us to observe but does not promise clarity on our timeline. As we wait for confirmation, we drift in a rare moment, an interval between event and understanding. The comet has delivered its message. Venus is translating it. Mars is storing it. And we, suspended in curiosity, are listening to the slow transformation of two worlds. Tonight, allow that patience to soften you. Let the waiting become a kind of peace. Remember that not all mysteries must resolve quickly. Some are meant to unfold in cosmic time, not human time. You are not lost in space, traveller, you are part of it. Sleep with that knowledge. The cosmos will keep watch. Traveller. Tonight we drift deeper into the chemistry unfolding within Venus's clouds, where something rare is becoming visible. Not life, but the quiet architecture that sometimes precedes it. For decades, Venus has been treated as the universe's great reminder of what happens when a world collapses into heat and acid. Yet the comet's arrival revealed something humbling. The rules we thought were absolute were never absolute at all. For years, the scientific narrative declared that Venus sterilized everything. Its sulfuric acid clouds were assumed to erase organic molecules instantly like a flame-touching paper. But now, evidence whispers a different story. Experiments on Earth show that most amino acids, the very building blocks of life, can withstand Venus-like acid concentrations. 19 out of 20 remained intact, their structures unbroken, even in an environment we once viewed as impossible. This revelation reshapes the lens through which we view 3I Atlas's delivery. Hydrogen, cyanide, water, and organic fragments were not erased. They persisted. They transformed. They entered reactions that should never have been available in the first place. The clouds of Venus, once seen as a place where chemistry went to die, now appear capable of hosting the early steps of prebiotic complexity, however fleeting those steps may be. Imagine a droplet forming in the upper cloud layer where temperatures hover near freezing. Inside it, sulfuric acid water ammonia produced from HCN breakdown formic acid, and traces of nickel ions delivered from the comet. The droplet is small, microscopic, delicate, yet within it chemistry unfolds like a slow-motion storm. Bonds break and reform, structures assemble, some reactions halt abruptly, others stretch into new configurations. Each droplet becomes a floating microreactor. Each reacts independently without awareness, without intention. In billions of droplets, billions of tiny experiments run in parallel, only a few will produce anything interesting. Yet in chemistry, rarity is not a barrier. It is the rule from which complexity emerges. The interplay of acid and water creates narrow windows where certain molecules can survive long enough to interact meaningfully. Ammonia, a base in an overwhelmingly acidic environment, creates small sanctuaries, pockets of reduced acidity, where fragile organics can exist without immediate destruction. These microenvironments do not remain stable forever, but they persist long enough for reactions to occur, for structures to grow, for the universe to test another path toward complexity. Catalytic nickel deepens the intrigue. When nickel ions dissolve into droplets, they accelerate reactions that Venus alone could not produce. They lower energy barriers, allowing transformations that would otherwise take geological timescales. Nickel enables small chains to form from smaller fragments, nudges organics into more complex shapes, and catalyzes reductions that carry echoes of early Earth chemistry. It is not life, but it is life like chemistry. Traveller, let yourself picture this on a planetary scale. Millions of droplets rise and fall through the clouds. Each droplet evolves chemically as it journeys through different temperatures and pressures. Some reach zones where UV radiation fractures them. Others sink into darkness, sheltering fragile molecules longer. The entire cloud deck becomes a dynamic, multi-layered landscape of reactions, a soft hum of experimentation carried by the winds. It is breathtaking to consider that such a hostile world might temporarily host chemistry with the same building blocks that once shaped life on Earth. Not because Venus is gentle, but because chemistry itself is stubborn, persistent, and creative. The universe does not reject possibility. It tests it everywhere, even in the darkest or most acidic corners. And still, traveller, there is humility in this. These reactions are not marching toward life. They are wandering, exploring, fading, reforming. They have no goal, no direction, no purpose beyond the quiet expression of physics and chemical potential. Life requires far more stability, replication, protection, and time. Venus offers none of these in a sustainable manner, yet for a brief moment it offers exploration, and exploration is the seed from which wonder grows. Weeks after the comet's arrival, this chemistry continues not as a spectacle but as a whisper. Photochemical destruction repeats daily. Circulation moves droplets to harsher altitudes. Complex structures form and then dissolve back into precursors. Yet the possibility remains active, the system not yet returned to its ancient equilibrium. To scientists observing from afar, these processes exist only in inference. We cannot see droplets forming peptides or organics assembling in miniature. We see their signatures in directly slight shifts in absorption lines, unexpected scattering patterns, hints of molecules in spectral shadows. Understanding Venus requires interpreting absence as much as presence, reading silence as carefully as signal. This is the paradox of planetary science. A world 38 million kilometers away can reveal a transformation so subtle it could be erased in minutes, yet profound enough to reshape our understanding of where prebiotic chemistry can thrive. Venus becomes not a failed Earth, but a test case, a reminder that the conditions for complexity exist in places we once dismissed entirely. And so, traveller reflect on this gentle truth. The early universe did not produce life in a single environment. It experimented across frozen worlds, molten worlds, acidic worlds, ocean worlds. Complexity was never localized. It was universal potential waiting for the right balance of time and shelter. Venus, for a fleeting season, joins that cosmic experimentation, participating in a story older than planets themselves. As the days pass, the comet's materials will continue their decline. Sunlight will break them apart. Circulation will dilute them. Droplets will evaporate and rise again, purified back into Venus's familiar cycle. Eventually, the perturbation will fade completely, leaving behind only data memory and altered understanding. But before that happens, traveller the clouds hold their breath. They process, they transform, they whisper possibilities only chemistry can hear. Tonight rest in this thought. Somewhere beyond our reach, something ancient still moves. Chemistry dreams in the clouds of Venus, and in that dreaming the universe reminds us that even in acid and fire wonder survives. Sleep gently. The cosmos will keep watch. Traveller. Tonight we enter the heart of the mystery, the role of nickel, the catalyst that arrived quietly inside dust grains from an interstellar visitor. What Venus received was not merely foreign matter, but foreign capability. Nickel does not simply exist in chemistry, it enables chemistry. It is the invisible hand that lowers barriers, allowing reactions to unfold that would otherwise remain dormant for ages. In Venus's clouds, this catalyst becomes the spark that brightens the edges of possibility. Imagine the moment nickel touches sulfuric acid. It dissolves instantly, releasing ions into droplets that have drifted unchanged for eons. The droplets, once simple agents of Venus's internal cycles, now possess catalytic properties they have never known. Reactions that normally require immense energy begin to flow more easily. Water reacts with carbon monoxide. Organic fragments rearrange. Hydrogen forms and sometimes escapes into space, carrying with it the faintest exhale of planetary change. The water-gas shift reaction becomes the most striking example. Carbon monoxide and water coexist in the droplets, but without a catalyst they move past each other like strangers. Nickel introduces them. It lowers the energy required for their interaction. Suddenly carbon monoxide transforms into carbon dioxide and hydrogen, a shift that reverberates through local chemistry. Hydrogen rises light and restless, while carbon dioxide grows denser, altering microcurrents within droplets. This subtle rearrangement matters. Even slight changes in buoyancy or chemical composition can ripple through Venus's atmospheric layers. Droplets become tiny engines of transformation powered not by heat or light, but by catalytic permission. Nickel does not consume itself in these reactions. It participates again and again, cycling through droplets as the winds carry them around the planet. A single ion drifting for weeks may facilitate millions of reactions before fading into unreactive forms. In industrial settings on Earth, nickel drives the formation of long carbon chains, the basis of fuels plastics, and countless organic materials. In Venus's clouds, similar reactions become possible in miniature. Conditions are not ideal. Temperatures, pressures, and acid concentrations vary widely. Yet within certain droplets at certain altitudes, combinations may arise that mimic the earlier steps toward organic complexity. Not life, but scaffolding. Not purpose, but potential. Think of complexity as a wandering traveller itself, moving where conditions briefly align, forming structures that collapse and reform as they drift. In Venus's upper layers, nickel guides these wanderings. Reactions become smoother, more frequent, more expressive. Chains lengthen before breaking. Radicals recombine in unexpected shapes. Chemistry begins to explore its own edges, feeling out possibilities with the patience of a planet and the curiosity of entropy itself. Some droplets rise into intense ultraviolet light where their contents shatter into radicals. Others sink into cooler shadows where fragments have time to assemble again. Vertical circulation becomes the heartbeat of experimentation, lifting and lowering each reactor through environments that challenge and refine its chemistry. The droplets do not know they are participating in something profound, but the cosmos often works through unknowing agents. Traveller, listen closely. This is how complexity emerges in the universe. Not through intention, but through repetition. Not through design, but through opportunity. A catalyst arrives. A condition shifts. A reaction flows more easily. And from this chain of quiet allowances, structures take shape that were once impossible. But Venus's catalysis does more than facilitate. It challenges the narrative we've told ourselves about where chemistry can thrive. We once believed acid meant death. Now we see it can mean persistence. We once believed heat erased possibility. Now we witness complexity forming above it. The comet's delivery reveals a universe far more permissive than we expected. Think of the earliest Earth full of volcanic gases, metal, rich minerals, radiation, and chaos. Yet within those harsh conditions, catalysts played their silent roles, guiding reactions that eventually led to life. Venus is not repeating Earth's story. It is writing one of its own. Still, the echoes remind us that complexity often begins in places we underestimate. Now consider the scale. Billions of droplets, each holding different combinations of water-acid organics, ammonia, and nickel. Billions of reactors rising and sinking through atmospheric domains, experiencing cycles of darkness, ultraviolet light compression, and expansion. The entire cloud deck becomes a planetary laboratory not designed, not controlled, but breathtaking in its breadth. Most reactions lead nowhere. Most structures dissolve. Most experiments fail. Yet chemistry is patient. It tries again with every droplet, every circuit, every interaction. Failure is not an obstacle. It is the default state that makes rare successes meaningful. Instrumentation on distant spacecraft now attempts to read this shifting puzzle. We look for traces of nickel compounds, for changes in cloud reflectivity, for chemical fingerprints that indicate catalyzed reactions. The signals are faint, blurred by heat and haze, but they are there. Science listens to these signals like a stargazer watching faint constellations appear through fog, trusting that meaning lies behind the subtle. Traveller, allow yourself to rest in this mystery. You're witnessing chemistry that has not occurred here for billions of years. Foreign molecules delivered by an interstellar messenger now circulate through a hostile world, producing reactions Venus has never known. Catalysts expand what is possible. Droplets become vessels of transformation. This is not a path toward life. It is a reminder of chemistry's infinite creativity. Tonight, as you breathe slowly, imagine the clouds of Venus glowing faintly in the filtered sunlight, each droplet carrying memory from another star system. Imagine nickel drifting through acid, encouraging molecules to speak with each other in languages older than biology. Imagine complexity rising briefly from heat and haze, only to dissolve again into silence. And in that silence, remember, Some mysteries aren't meant to be solved, only observed. You're not lost in space, you are part of its unfolding. Sleep now, traveller. The cosmos will keep watch. Traveller. As we drift deeper into this unfolding story, the comet's journey reveals something more profound than chemistry alone. 3 Atlas did not touch only one world, it brushed against 2. Mars cold and silent, Venus hot and restless. 2 planets receiving the same gift, yet responding as differently as stone and flame. In their divergence lies a lesson about how worlds behave, how environments shape possibility, and how the universe expresses creativity through contrast. Let us begin with Mars, the archivist of the solar system. When the comet's materials fell onto its thin atmosphere and frozen terrain, nothing stirred. The molecules simply landed intact, undisturbed, preserved in cold storage. Mars does not transform what it receives. Instead, it keeps it like a vault of ancient secrets awaiting hands that will someday open it. Without warmth, without circulation, without chemical weather, the comet's gift rests there unchanged, waiting for robotics and sunlight in years to come. Venus, however, is a different story entirely. It does not store, it processes. It takes what arrives and folds it into its atmosphere the way a living ocean absorbs rain. The materials do not rest, they begin reacting instantly. Hydrogen cyanide hydrates. Water reshapes droplet acidity. Nickel awakens catalytic pathways. Venus behaves like an alchemist, a world that transforms the unfamiliar into a new expression of itself. This difference defines the next chapter of our cosmic tale. Mars represents patience, cold, inert, timeless. Venus represents immediacy, hot, dynamic, consuming. The same interstellar material now experiences 2 extreme fates, one frozen in place, one set into motion. The comet's visit becomes a natural experiment across worlds, offering science a rare opportunity to watch chemistry diverge as though in parallel universes. On Mars, nothing will change until humans or robots intervene. The chemistry waits pause between possibility and action. It will take excavation analysis and industrial processing to reveal what lies within the samples. Mars becomes a collaborator in the future, not the present, a participant only when touched by machines guided by human intention. But Venus does not wait for us. Its atmosphere acts instantly. The comet's materials are already dispersed across global winds, already entering photochemical cycles, already contributing to new reactions. For Venus, the story began the moment the molecules arrived. For Mars, the story begins years after, when exploration tools reach the deposit sites. This duality shows us something humbling about planetary behaviour. We often imagine worlds as passive spheres of rock that simply exist. But in truth, each one has a personality shaped by gravity, temperature, pressure, and atmospheric design. Mars is a keeper of records. Venus is a maker of change. And 3I Atlas treated them as such, delivering identical cargo into 2 different fates. Traveller. Imagine the comet itself as it crossed the inner system. A wanderer from interstellar darkness carrying chemistry forged near another star. It passed Mars first, cold quiet, barely reacting. Then, Venus hot alive with circulation immediately reshaping what it received. The comet did not decide where its influence would matter more. Nature did. And in that difference we learn how chemistry becomes biography. What unfolds next is not a competition, but a contrast. Mars's deposits will be studied years from now, their reactions triggered by excavation heating and the algorithms guiding robotic industry. AI systems will melt, regolith analyze isotopes, detect organics, and perhaps reveal signs of interstellar pre-processing. Mars's transformation will be technological, a merging of alien chemistry and human ingenuity. Venus, meanwhile, undergoes a transformation free of intervention. It reacts in real time, guided only by physics and sunlight. The comet's molecules dissolve, recombine, break apart, ascend, descend, and drift through layers that have not changed for billions of years. Venus's transformation is natural and unprompted expression of planetary curiosity. This distinction carries profound implications for astrobiology. Mars shows how preserved organics may survive across eons. Venus shows how active atmospheres respond to novel inputs. Together they expand the boundaries of where complexity may arise or persist in the universe. They become two halves of a wider lesson, one about endurance, one about transformation. The scientific community watching from afar now holds two mysteries instead of one. How deeply did the comet's chemistry penetrate Mars's surface, and how broadly did it alter Venus's atmospheric pathways? These questions will take months, even years, to answer, but they will redefine how we interpret interstellar visitors, planetary chemistry, and the quiet exchange of matter across cosmic distances. In the coming years, Mars missions will uncover frozen signatures of 3I Atlas. Engineers will notice anomalies, efficiency improvements, unusual reaction rates, surprising yields. Only later will someone connect the dots the comet's deposits subtly altered the chemistry of the regolith. What begins as a technical puzzle will become a scientific revelation. Venus, on the other hand, will reveal its story earlier. Spectral data circulation models and photochemical analysis will piece together a timeline of transformation. Researchers will debate how long the foreign molecules persisted, how they influenced droplet chemistry, how catalysis unfolded. The answers may be subtle, traced in fingerprints of light rather than samples, but they will reshape our expectations of what is chemically possible in extreme environments. Traveller, consider what it means to witness both transformations at once. Two planets responding to the same cosmic visitor in two profoundly different ways, one storing, one transforming, one waiting. This duality is not accidental. It is the universe teaching through contrast. As you breathe slowly, imagine the comet's molecules resting silently beneath Martian dust, while millions of others drift through Venusian clouds, dissolving into the breath of a planet that refuses to remain chemically still. Two fates from one origin, two stories from one encounter. Let that duality soften your thoughts tonight. Not all worlds respond the same way. Not all mysteries unfold on the same timeline. Not all transformations require our presence. You're not lost in Space Traveller, you're witnessing its ongoing dialogue. Sleep now. The cosmos will keep watch. Traveller. As we move deeper into this cosmic narrative, the story shifts from chemistry towards something quieter. The unfolding of understanding. What happened on November 3rd was not simply an event, it was the beginning of an 18-month journey, in which observation becomes theory, theory becomes debate, and debate becomes the slow crystallization of truth. In science, revelation rarely arrives with thunder. More often it emerges like dawn, faint, patient, impossible to hurry. Right now, the instruments that watched Venus are silent, their data already sent across millions of kilometers. The scientists who study them now sit in rooms lit by monitors, comparing spectral lines, adjusting models, questioning assumptions. They work not in haste, but in devotion. To understand a planet is to listen without interruption, to give attention to whispers you might otherwise ignore. Venus sends only whispers, yet whispers can reshape worlds. The waiting itself becomes part of the discovery. Before the comet's encounter, we thought we knew Venus a world sealed in a closed loop of heat, acid, and repetition. But new molecules have disturbed that equilibrium, and disturbance always invites interpretation. Researchers know the answer exists. It is encoded in the light that passed through the clouds. But extracting that answer takes time. Just as clouds circulate slowly, meaning circulate slowly too. From January to March, the first papers will emerge like early stars. Some will confirm elevated water vapour. Some will detect traces of hydrogen cyanide or carbon monoxide in places they should not be. Others will outline shifts in cloud reflectivity or unexpected scattering patterns. Each paper will offer a fragment, a shard of a larger truth yet to be assembled. Science does not reveal itself in whole stories. It reveals itself in pieces that must be patiently woven together. At the same time, Mars will reveal its own data infrared maps, composition shifts, and anomalous surface signatures indicating where the comet's deposition settled. These findings will not show transformation not yet, but they will show potential. Mars does not react now. It reacts later when robots unearth what the comet buried. Two planets responding in two timelines, each guided by its own nature. By April, the modelling phase begins. Researchers will take the data and build simulations of Venus's atmosphere. They will ask, how long did the foreign molecules persist? Which reactions dominated? Where did the catalytic effects peak? Which pathways happened that we have not yet imagined? These models will fill in the gaps between observation and possibility, forming a bridge across uncertainty. You see, Traveller, even when the data is incomplete, the universe still leaves enough clues to trace its intentions. By summer, mission planners will refine future spacecraft designs. A world once thought chemically predictable now demands new instruments, new spectrometers, new probes, new strategies for sampling droplets in motion. Venus becomes not a dead end but an active frontier, a place where complexity flickers unexpectedly in acid and wind. The comet did more than deliver molecules, it awakened curiosity on Earth. Meanwhile, 3 Atlas drifts outward, fading from view. Its role is complete. It has delivered its message. 2 planets heard it. Now humanity tries to translate it. By early 2027, something beautiful happens. Patterns become visible. Mars's processing data will show subtle anomalies, water extraction more efficient than expected temperature curves, slightly altered catalytic effects emerging in regolith heated by robotic furnaces. Engineers will notice first. Scientists will confirm later. What began as foreign dust becomes measurable influence. Venus too will tell its story more clearly. Follow-up observations will show whether the chemistry has fully dissipated or left lingering traces. If certain organic signatures persist longer than predicted, it will challenge our models of acid destruction. If nickel-driven catalysis left a chemical fingerprint, it will redefine our understanding of atmospheric chemistry on terrestrial worlds. And through all this unfolding, Traveller humanity will come to recognise something profound. Planets respond to cosmic encounters, not with uniformity but with individuality. Mars holds stillness like a stone. Venus embraces transformation like a flame. One preserves, one processes, one waits for us, one moves without us. 2 worlds receiving the same chemistry yet choosing different destinies. In this comparison lies the heart of planetary science, not to categorize worlds, but to understand the personalities written into their physics. A world is not merely rock and gas. It is behavior unfolding across time. Tonight, allow this realization to settle gently. We are witnessing a moment that will become a cornerstone of planetary understanding. Not dramatic, not catastrophic, but quietly revolutionary. The first time in human history, we have seen 2 planets respond to the same interstellar visitor, one through silence, one through change. Traveller, let this calm you. In a universe of immense distances, meaning still finds ways to reach us. The comet has passed. The chemistry continues. The data waits. An understanding approaches slow but inevitable, like the turning of a planet beneath its own sky. Rest now, beneath that sky. You are not lost in space. You are part of its unfolding story. Sleep gently. The cosmos will keep watch. Traveller. Tonight we arrive at the stage where Venus, after its burst of chemical novelty, begins the long drift back toward equilibrium. Nothing in planetary chemistry is permanent, not even the disruptions born from an interstellar visitor. The comet delivered its gifts, Venus received them, and now the atmosphere, ancient and self-governing, begins to settle slowly, methodically, as though exhaling after a moment of excitement. But returning to equilibrium does not mean returning unchanged. Every perturbation leaves an echo, a shift in understanding, a record tucked between layers of cloud and chemistry. Venus is already letting the first signs of normalization appear, droplets reforming into their usual compositions, radicals fading from sunlight-driven reactions, circulation patterns, smoothing back into their familiar rhythm. Yet even as this restoration unfolds, the traces of Through Atlas linger like afterglow on the horizon. The comet's water is the first to move toward disappearance. It evaporates, dissociates under ultraviolet light, or is diluted into the vast acid reservoirs of the cloud layers. Hydrogen escapes upward light and restless, sometimes drifting into space. Oxygen merges with carbon, sulfur, or chlorine compounds, vanishing into Venus's chemical networks. What began as a few dozen tons of interstellar water becomes scattered across reactions, too numerous to track individually, yet meaningful in their collective disturbance. Hydrogen cyanide too begins its dissolution. It hydrolyzes into ammonia, decomposes into radicals, or is transformed into organics that persist for days before breaking apart. None of it lasts long on cosmic timescales. But for a brief season, those molecules wrote themselves into the atmospheric story of a planet that had remained chemically isolated for billions of years. A whisper does not stay in the air forever, but it can change the listener. Nickel, however, behaves differently. It dissolves, yes, but it does not vanish quickly. Catalysts can influence reactions long after smaller molecules have disappeared. A single nickel ion may pass from droplet to droplet, accelerating transformations weeks or months beyond the initial encounter. Even when bound into unreactive forms, its brief, catalytic life leaves a memory etched into the resulting chemical products. This lingering influence matters to scientists watching from afar. Every catalyst that moved through the cloud layers altered pathways, encouraged. New structures shifted the timing and abundance of reactions. The results will not be dramatic. No new life, no runaway system change, no transformation visible from orbit. But the echoes of catalytic chemistry may persist long enough to be detected in the spectral fingerprints of cloud droplets. A trace, here, a shift there, a deviation from expected equilibrium. These small anomalies become evidence that Venus responded to its interstellar visitor with quiet, intricate chemistry. Traveller. Imagine the atmosphere from above, a layer of pale gold and soft white circling the planet in 4 Earth days. Within that brightness, droplets rise and fall, evaporate and reform, carrying the last remnants of foreign molecules through their endless circulation. Each droplet is both a memory and an experiment, a place where the universe briefly tried something new before returning to its familiar rhythm. This interplay of disturbance and restoration reflects a deeper truth about planets. They are not static. They are systems that absorb, transform, and eventually resolve disruptions. Venus does this through heat acid and sunlight. Mars does it through stillness and cold. Earth does it through life oceans and weather. Each world has its own form of resilience. By January or February, most of the comet-delivered chemistry will fade into the background. But the understanding of what happened will only begin then. Scientists will reconstruct the event with models layering atmospheric simulations over recorded data, seeking consistency between prediction and observation. They will ask, how fast did the water disperse? Which reactions dominated? What was the lifetime of HCN-derived organics? How deep did nickel catalysis influence droplet chemistry? Each question becomes a thread, and Venus's atmosphere becomes a tapestry woven through computation and imagination. What remains most fascinating is not any single reaction, but the way all reactions interacted at scale. Chemistry in a planetary atmosphere is communal. Molecules influence each other not in isolation, but in systems that evolve every second. Venus's return to equilibrium is not a rewind. It is a rebalancing shifted slightly by the encounter. A new equilibrium shaped by involvement with something foreign and traveller. This is the part where awe returns. Because what Venus experienced is not unique. Across the galaxy, comets pass close to planets every day. Atmospheres receive foreign chemistry. Worlds shift even slightly in response. Yet we here on Earth witness such an exchange directly in real time with instruments capable of capturing its subtleties. We are witnesses to a universal process rarely observed. In these final days of the perturbation, Venus feels like a symphony easing into its closing notes. The tempo slows, the harmonies resolve, but the resonance remains vibrating softly through the atmosphere long after the final reaction fades. And somewhere far beyond telescopes and models, the comet continues its outward path, silent, indifferent, carrying the next chapter of its cosmic biography. It leaves behind not chaos but curiosity, not answers but questions, not transformation but the memory of transformation. As you rest tonight, traveller, let that memory settle within you. Even brief encounters shape the fate of worlds. Even small molecules leave echoes. Even silence carries meaning. You are part of that same universe shaped by encounters restored by time, always moving toward a new equilibrium. Sleep softly. The cosmos will keep watch. Traveller. As Venus slowly drifts back toward its ancient rhythms, another story begins on Earth, the story of verification. Observing a phenomenon is only the first step. Understanding it requires patience, humility, and the willingness to sit inside uncertainty. Humanity now enters this stage where data transforms into insight with the same slow, deliberate movement that planets use to orbit their star. Across observatories, teams sort through the measurements collected during the comet's passage. Each photon of light captured by Akatsuki carries a fragment of meaning, a spectral bend, a colour shift, a faint dip in absorption. These fragments are delicate, easily misread. Scientists must treat them like whispers from a distant world, careful not to assume, careful not to rush, careful not to impose certainty where only suggestion exists. This is the quiet labour of science traveller. Long before conclusions emerge, there are hours of calibration, nights of comparison, weeks of correspondence between teams across the planet. Someone in Tokyo adjusts a model. Someone in Pasadena questions an anomaly. Another scientist in Berlin overlays wind simulations with observed scattering. Together without fanfare, they begin to assemble a mosaic of truth. Meanwhile, ground-based telescopes continue tracking Third-Eye Atlas as it slips away from the inner solar system. Even from a great distance, the comet still carries the remnants of its encounter, spectral hints of water loss, diminishing cyanide production, dust patterns altered by solar radiation. Tracking its decline creates the baseline against which everything at Mars and Venus must be interpreted. Traveller imagine the scientists who now wait for these answers. They are not idle, they are listening. Listening to the data, to models, to each other, to the behaviour of worlds. They have learned that rushing truth only pushes it further away. Understanding comes not through force, but through quiet attention. The months between December and March become a kind of scientific dusk, not dark, not bright, but filled with fragile illumination. The first preprint papers appear tentative and measured, offering early insights without overreach. They speak of trace detections, small deviations, subtle anomalies in cloud reflectivity. No single discovery stands alone, but together they weave a pattern. Venus was touched, and something within it shifted. Mars too begins to reveal signs of deposition. Spectrometers on Mars Reconnaissance Orbiter detect faint traces of nickel and organics in the southern highlands. Thermal anomalies hint at disturbed regolith in places aligned with the expected deposition pattern. Each discovery is small, almost forgettable if it were not for the context. But within context, they become footprints left by a traveller crossing frozen sand. These early results do not answer the deeper questions. They simply confirm what happened physically. Material arrived, and the planets received it. But science often begins with confirmation of the obvious before it reaches toward the profound. By spring, the deeper modelling begins. Atmospheric chemists simulate Venus's upper clouds under thousands of permutations, adjusting water concentration, catalytic presence, droplet pH, and circulation speed. They compare predicted outcomes against the observational data. They refine parameters until the models breathe, approximating reality, though never fully capturing its complexity. At the same time, geochemical modelers chart how comet-delivered metals might behave on Mars under robotic heating conditions expected in 2027. They test reaction pathways, catalytic effects, mineral transformations. The work is slow, meticulous, and surprisingly beautiful, a study of how alien chemistry meets planetary character. Traveller. Notice how all of this unfolds long after the comet has passed. The event is over, but the meaning continues to unfold. This is the nature of cosmic stories. Their echoes last longer than their moments. By early summer, synthesis papers emerge. These papers, unlike the early ones, attempt to place everything into a coherent narrative. They show how foreign molecules move through Venus's cloud layers. They illustrate how reactions unfolded over days and weeks. They explain which chemical signatures should have persisted long enough for detection. These papers do not speak in absolutes. They speak in probabilities, in likelihood shaped by physics rather than certainty. The unexpected becomes part of the narrative. The persistence of certain organics longer than predicted. The catalytic influence of nickel stronger than models initially assumed. the distribution of water vapour uneven in patterns that hint at deeper circulation structures. Each of these anomalies becomes a doorway, a small opening into a larger understanding of Venus as an active, evolving chemical system rather than a static inferno. And yet, Traveller, the most remarkable shift happens not in the data, but in human perception. Everything we learn from Venus pushes the boundary of where complicated chemistry can thrive. Everything we learn from Mars expands our sense of how long foreign molecules can endure without degradation. Together they enlarge the map of cosmic possibility. The scientific community now sees something they did not fully appreciate before planetary responses are stories. They have beginnings, middles, and ends. They differ in tone, in pace, in dialogue. Mars speaks softly through persistence and silence. Venus speaks in dynamic shifts, in turbulence and transformation. And humanity listens to both, learning to read each world as a unique participant in a cosmic conversation. Through all of this, the comet itself fades not in relevance but in presence. It drifts outward cold once more, leaving behind only the trail of questions it inspired. In a way, 3i Atlas becomes a teacher, whose lessons continue even after it has walked beyond the classroom door. Tonight, traveller, as you breathe slowly and feel the weight of quiet settling over you, remember this. The universe rarely reveals its truths in a single moment. Understanding is a slow orbit circling closer with each pass. You do not need every answer tonight. You only need the patience to let them arrive in their own time. Sleep gently. The cosmos will keep watch. Traveller. Tonight, we turn to the deeper reflection emerging from this interstellar encounter. The realization that Mars and Venus, so different in temperament, have become mirrors for each other. Not identical, not symmetrical, but reflective in their contrast. Their responses to 3i Atlas show us that planets, like people, reveal themselves most clearly when touched by something foreign. Mars receives quietly, Venus reacts instantly. Yet both worlds in their distinct ways are telling us something about the architecture of change, how environments either protect what arrives or reshape it, how conditions sculpt possibility. The comet did not simply deliver chemistry, it delivered perspective. It allowed us to see the inner workings of two neighbouring planets in ways impossible before. Mars now holds the comet's materials in stillness. The deposits lie beneath frost and dust, unchanged and almost ceremonial. Time does not move quickly there. Nothing stirs unless technology intervenes. If the comet's molecules carry memory from another star system, Mars preserves that memory with the devotion of an archivist. Cold, silent, patient. Venus, by contrast, took the same material and wove it directly into its atmospheric tapestry. No hesitation, no preservation, only transformation. A world of heat and pressure responded with chemistry that unfolded like a story written in vapour and light. Where Mars is, a pause, Venus is motion. Where Mars waits for years, Venus acts within minutes. This dual response becomes a rare opportunity, an experiment orchestrated not by scientists but by celestial alignment. Two worlds receiving identical inputs displaying radically different outputs. A natural laboratory with outcomes that no human could design. Traveller, consider what this means for the way we search for life. For decades we've built our expectations around Earth like environments, assuming moderate temperatures, stable water, gentle cycles. But Venus shows us that complexity can flicker even in acid, even in turbulence, even in a world that seems hostile beyond imagination. Complexity is not fragile, it is resourceful. It blooms wherever physics allows. Mars teaches a different lesson. Sometimes preservation is more valuable than transformation. Some worlds may not generate complexity, but they protect its clues. They hold on to history the way ancient ice holds air from forgotten eras. Mars might not process foreign molecules, but it keeps them intact long enough for us to study with clarity. Two worlds, two archetypes. The keeper and the alchemist. The archive and the reactor. The stillness and the storm. As scientists begin comparing the early data from both planets, a sense of humility spreads through the community. They realize that planetary behavior is not defined solely by composition, but by context, circulation, temperature, magnetic fields, pressure gradients, even timing. The comet arrived during specific seasons at specific latitudes. A different alignment might have produced entirely different outcomes. Meaning becomes conditional like starlight bent by gravity. By mid-2026, as models mature, researchers will begin to see how deeply this duality runs. Simulations of Mars will show deposition patterns preserved with uncanny clarity, nickel grains perfectly intact organics, embedded in regolith water molecules frozen into crystalline networks. Everything paused between arrival and future discovery. Simulations of Venus will show reactions branching into labyrinth's catalytic pathways, accelerated by nickel organics forming and dissolving in rapid cycles, droplets evolving like temporary microcosms. Everything moving, exploring, transforming. This comparison will reshape our understanding of chemistry in the universe. It will suggest that life, or the precursors to life, may not emerge solely in kindness. It may begin in storms, in acid, under pressure, in the chaos of hot atmospheres. The simplicity of the habitable zone becomes more complex, more poetic, more inclusive. Traveller! Let this widen your sense of possibility. The universe is not picky. It does not restrict creativity to comfort. It experiments everywhere in ice, in fire, in silence, in noise, in equilibrium, in disequilibrium. Planets become canvases and comets become brushes trailing chemistry across their surfaces. The next year of scientific publication will reflect this widening. Researchers will argue, propose, revise, retract and refine. Some will believe Venus produced short-lived complexity. Others will argue the effects were too subtle. Some will focus on Mars's untouched deposits. Others will insist the real story lies in Venus's catalytic pathways. This debate is not chaos, it is the rhythm of discovery. Science is not the search for instant consensus, but for durable truth shaped by careful disagreement. During this time, new missions will be proposed. Venus probes capable of sampling droplets directly. Mars landers designed to analyze subsurface chemistry, where comet products settled. These ideas will seem ambitious, yet suddenly more necessary than before. A comet has challenged our assumptions. Curiosity must now respond. And yet beneath all this activity a deeper reflection settles. Both planets behaved exactly as they were shaped to. Mars held, Venus changed. Neither failed, neither exceeded expectation. They simply revealed their nature, just as people do when touched by events outside their control. This is why the comparison between Mars and Venus resonates so strongly. It is not only scientific, but metaphorical. We see in these worlds a reflection of our own responses to disruption. Some of us store experiences quietly integrating them, only when we are ready. Others transform instantly, reshaped by every influence that crosses our orbit. Both strategies are valid. Both lead somewhere meaningful. Both are part of the cosmic story of adaptation. So tonight, traveller, rest in this truth: a comet, travelling for billions of years, brushed against two worlds, and each responded according to its own essence. You too respond to the universe in your own way, sometimes through stillness, sometimes through transformation. There is no wrong response. Only honesty. Only nature unfolding as it must. Sleep softly beneath this understanding. The cosmos will keep watch as it always has. Traveller, tonight we enter the softest territory of this story, the place where knowledge ends and mystery begins. After all the chemistry, modelling, observation and interpretation, we finally meet the part of the universe that refuses to be fully measured. This is not a failing of science. It is the nature of wonder. Some truths appear only as silhouettes, visible not in detail, but in outline. For months, Venus and Mars have carried the comet's touch like a faint memory. Each responded according to its internal character, Venus through transformation, Mars through preservation. The chemical traces may fade, but the meaning does not. What 3 Atlas delivered was not just matter, but perspective. It changed how we see planets, how we view disruption, and how we imagine cosmic possibility. Consider Venus Traveller, a world dismissed for decades as too hostile, too acidic, too hot for relevance. Yet when foreign molecules arrived, Venus did not destroy them instantly. It experimented with them, dissolving, recombining, catalyzing, moving them through circulation layers older than continents. For a brief season, that planet became a vast unintentional laboratory, drifting beneath sulfuric clouds. Now that chemistry fades, but something deeper lingers. Not a molecule, a realization. Stability is not silence. Hostility is not emptiness. Even worlds wrapped in acid and heat contain hidden capacities for complexity. Venus reminds us that chemistry is opportunistic. It moves anywhere conditions permit. And possibility, even if brief, is still possibility. Mars teaches a different but equally profound truth. There the comet's dust lies still preserved in cold regolith and silent basins. The molecules remain intact, unchanged, waiting for future missions. Mars does not transform what it receives, it shelters it. It becomes an archive of interstellar memory, storing fragments of another star system with the patience of a world that has always known how to endure. Two worlds, two responses, one cosmic visitor binding them in a shared story. And now humanity waits for synthesis, for data to become understanding, for models to become meaning, for debate to settle into the first outlines of truth. Yet even when knowledge arrives, it will not close the mystery, it will only deepen it. Traveller, this is the grace of uncertainty. We often chase science as though its purpose is to eliminate the unknown, but the cosmos invites us into a different relationship, one where not knowing becomes a form of reverence. The vastness of space does not diminish us, it opens us. The unfinished edges of discovery are where wonder breathes most freely. Think of early Earth 4 billion years ago. Volcanic oceans, violent storms, minerals dissolving into heat, chemistry unfolding without witnesses. No one saw the first bond form, the first chain assemble, the first improbable step toward life. Yet those invisible beginnings shaped all that followed. Absence of observation does not erase significance. In the same way, no one will ever watch the molecules inside Venus's droplets combine, catalyze, dissolve, or evolve. No camera will testify, no probe will witness the moment complexity flickers inside acid clouds. But chemistry unfolded regardless. The truth happened without needing to be seen. This is the humility the universe asks of us. Not all mysteries occur for our eyes. Some simply occur, and that is enough. Meanwhile, humanity continues to listen. Akatsuki's data is dissected line by line. Mars's spectral maps reveal quiet anomalies. Ground observatories track the comet's dimming tail as it returns to darkness. Every effort brings us closer to understanding, yet every step reminds us how much remains beyond our reach. The cosmos thinks slowly, and we must learn to follow its rhythm. Imagine a scientist alone at midnight analysing a faint spectral dip. In that small deviation lies evidence of an interaction between a star traveller and a planet wrapped in acid. A realisation dawns quietly, not dramatic, not loud. Simply a soft recognition that they're witnessing something ancient, something vast. Silence fills the room, but it is not emptiness. It is awareness. Because truly, silence is the universe thinking. Months from now, papers will appear describing what happened on Venus. They will speak of catalytic pathways, persistence times, anomalous scattering redistributed chemistries. Yet none will capture the full poetry of the event. Science gives precision, but not always meaning. Meaning lives where explanation ends. The comet did more than alter clouds. It altered imagination. It reminded us that planets are not passive. They are participant systems responding to cosmic influence in ways we cannot fully predict. Even in a mature solar system, novelty is still possible. Change is still possible. Experimentation is still possible. This shift in perspective becomes the comet's true legacy. The molecules will vanish, but the questions will remain. Can prebiotic chemistry spark in acid clouds? Can catalysts reshape atmospheric pathways? Can hostile worlds host transient complexity? We do not have answers yet, but the asking itself widens the world. Traveller, what Venus experienced this year may never be repeated, but the influence of that experience on science, on imagination, on our understanding of planetary possibility will echo for decades. Meaning does not require permanence. A meteor leaves a crater. A comet leaves a question. And sometimes a question is more powerful than an answer. Tonight, as you drift towards sleep, let this truth settle softly around you. Not every mystery must resolve. Not every phenomenon demands conclusion. Some exist only to remind us how large the universe is and how gently it invites us to wonder. You are not lost in that universe. You are part of its unfolding, part of its questions, part of its listening. Rest now, traveller. Now. The cosmos will keep watch. And so, traveller. Our journey drifts to its soft ending. We have followed Three-Eye Atlas from the edge of interstellar night to the glowing clouds of Venus, watching a world older than memory react to something it has not touched in billions of years. What happened there is still unfolding, still whispering through chemistry, still echoing across models, still deepening the mystery we share. Even now, as you listen, Venus is carrying those molecules through its winds. Mars is holding its own quiet archive beneath frozen dust. And somewhere far beyond our reach, the comet continues its silent retreat, leaving us with questions that will take months, maybe years to understand. Yet that, listener, is the beauty of this story. Discovery does not arrive all at once. It arrives like dawn, slowly, gently revealing only what we are ready to see. Tonight, let yourself rest in the knowledge that you are part of this unfolding. Not a distant observer, but a participant, someone who looks upward and helps keep the universe alive simply by paying attention. In a cosmos so vast, curiosity is its own form of gravity. What happens next will come in its own time. For now, allow the mystery to remain open. Allow the silence to breathe. Rest well, traveller. Stay curious. The universe will keep watch,